Chapter 6, Periodic Properties, Homework, question number 4. Arrange selenium, gallium, and arsenic in terms of increasing the effective values acting on a valence electron. Assume that the valence electrons contribute nothing to the Z effect values. So please recall the ZEFF that actually is the effective nuclear charge, and that can be calculated by using Z minus S. Z is simply the atomic number, and that of course also the total charge, nuclear charge, because protons are in the nucleus. So therefore Z is just atomic number and also equals the number of protons. What is S? S is the screening constant. It happens to be the core, the number of core electrons. Okay, so now we need to write down the electron configuration for each element. In order to do that, we need to find out the total number of electrons of each atom. So the first one, selenium, Se, that should be 33. Okay, so actually 34, I'm sorry, 34. Okay, and I'm going to use the shorthand notation or condensed electron configuration. In order to do that, you go one period up, so, and then take the last element electron configuration as the core. So in the shorthand notation, so therefore I will just simply write down AR, then with a pair of brackets. Remember we did that in previous sessions. So, and I should have 18 electrons. So 34 minus 18, we just need to assign whatever the difference. So for the, as the valence electrons, all right? So therefore, this is what I'm going to do. Okay, selenium, so argon, so that's actually the core electrons. Then this is the valence shell electron. Okay, argon itself has 18, we just talked about that. And then that's 20, that's 30, 34. Okay, so therefore, selenium has 34 electrons, and also means the atomic number Z is also 34. You see, we'll need both Z and S in this equation. So then this tells us what is the S. S is the number of core electrons, all right? That should be 18 right here. So S equals 18. We'll do the same for, let's see, the next one is gallium. Let's find out gallium. So that's 31. All right, should have a total of 31 electrons. Again, go to the last element in the previous period. That's still argon. So we'll use argon shorthand. Okay, so again, use argon as a shorthand notation for gallium. Gallium should have 31 electrons, as we just look at the, as we just got that from a copy of periodic table. So 31, let's count. Argon is 18, so therefore, the screening constant, or S, again, equals 18. 18, 20, 30, 31. You see? And Z also equals 31. Okay? So, and then the last one, arsenic, we'll do the same. We can just look at its atomic number. It's actually 33. You see, that's 33. So, and again, the previous periods, the last element right there, argon. We'll use that shorthand notation to represent the core electrons. Okay, so should have 33. Again, that should be 18 core electrons. And by definition, that's the screening constant. Screening constant. Okay, so 18, 20, 30, 33. And Z equals 33. So now I'm sure we are ready to calculate the ZEF. All right. So let's say for selenium, ZEF equals Z is 34 minus Is 18. Okay. So what should that be? 34 minus 18. Yeah, actually, we need to make one correction here. When we count the total number of core electrons, which is the screening constant, so we need to understand only the outermost energy level the electrons occupy, the outermost ones are counted as the core electrons. Even though you see this 3D, that's 3. Principal quantum number is 3. So in this end, it's fully filled. You see it's a 3D10. So then that can be considered as core electron. Okay? So therefore, the valence shell should be just 4s and 4p, not 3D. Okay? So therefore, that should be the core electrons, argon's 18, then plus another 10 3D electrons, that should be 28. And okay, so therefore minus 28, that should be 6 ZEF. The same thing for gallium, that should be 28. And then the ZEF, 31 minus 28, that's 3. And now arsenic, Z is 33, Is is 28, and that should be 5. Okay, so now we certainly can compare the ZEF values, or effective nuclear charges, for the 3 elements. So then we can write down those numbers. So in the order of increasing ZEF values. So therefore, the one with the lowest effective nuclear charge values, or ZEFF. So that should be gallium. The next one is 5, it's arsenic. And then the one with the largest effective nuclear charge is selenium. SE. Yeah, that's question number 4.